Okay, so this is 2018 hyperbolic paraboloid question. Now, if we read the question, we're asked to draw the given plan of elevation of the hyperbolic paraboloid ABCD. So again, using the number of elements shown. So we're asked to draw the bit within here first. And again, it's important that we follow the order of what we're asked, because typically there's a number of hints in the question. Usually what happens when people get it incorrect is that they start the question, they haven't looked at what exactly is asked of them, and they assume something or they miss a key point. Okay, so we're asked to draw the plan elevation hyperbolic paraboloid. And we're told the curve ABC is a parabola in elevation. So basically we're told this shape is a parabola. Draw the elevation. And then we're said project from the elevation to get the given plan of the outlying loop or project an end view. So everyone, when they look at that without reading the question, would assume that's an ellipse. But if we read the question, we're not told that's an ellipse. It might well be, but we actually have to project down from plan to locate those points. Okay, so we're not allowed to draw as an ellipse. Maybe it's slightly different to an ellipse, right? We're also then asked to draw the walkway in the end view. And again, it's important that we read that because we need space for it over here. Now, I'm not sure if this is going to fit. So if we have space, we'll do the end view. If we don't, we'll do it at an alternate time. Okay, so the first thing here is the scale is 1:500. So I suppose so far we haven't really encountered that too much. So the first thing you want to know is that in the exam you can bring in a calculator. The second thing you need to know is how many millimeters are in a meter. So there's 1,000 millimeters in a meter. So 8 meters will become 80,000 millimeters. So I'm just going to write it out here. I'm going to divide that by 500. Okay, so if that was the case, I'd knock off that 0 and that 0. I'd knock off that 0 and knock off that 0. I have to go 5 into 180. So 5 into 8 goes once and 3 over. 5 into 30 goes 6 times and nothing left, and then 160. So 180 has become 106, or sorry, 80 meters has become 160 millimeters. So if you look at that, you can say, well, right, well, that's been doubled. So once I understand it once, I could then make the same assumption for everything else. Now, again, I could double check it with my calculator for 1 or 2 more, but I'm quite happy from having done these a number of times. So basically I'm doubling it. So 32 becomes 64. I'm dividing it by 500, but I'm doubling it and converting it to millimeters. 7.5 becomes 15, 12 becomes 24, 45 becomes 90, 16 becomes 32. Okay, no harm to do this with a calculator, just to make sure you haven't made a mistake. And I'm just going over them now to double check. So I'm happy enough with that. So my height of my object here is 64 plus 15 by the looks of it. So I'd say if I come down 100, I should have loads of space. My width here, I'm not using an ellipse to draw it. Yeah, so that looks like that would fit fine. So I'm going to come down 100 and I'm going to draw a ground line. Okay. So there's my ground line. Now again, as I said, we'll see if we can fit in the end view. It may or may not fit. I have a feeling it won't. But what we'll do anyways is we'll keep as close to the side on the assumption that it might. Now we have a small problem in that we don't know this width here. We also have a new, what would you say, symbol here that some people may or may not be aware of. So if you do construction studies, you may have seen this symbol. So if you were drawing out a window detail or something like that, you may have noticed that. And what this symbol means is that the road continues on. So what they've done is instead of continuing on drawing the road continuously, they say this is a bridge. They've just done this to mean that it continues on. So usually where it happens would be if you were drawing the bottom of a door and then the bottom of the top of the door, instead of having to draw all the detail of the door, you may just put that symbol in and then go up 50 mil and then draw the top of the door, because nothing really changes. So usually it's when nothing really changes. So just in case you're a bit confused. Now, what I don't know exactly is what this width is, but I'm just trying to look at something that's already there. So if I look at the drawing and I say, right, well, that sticks out an extra 5 millimeters. So what measurement there? So that's about 3.5, so that's going to be 15 millimeters on the drawing. So we'll say it's going to come out, it's going to take at least double that, so it's going to be 30. So I'm going to come in 30 and I'm going to start from this point here, I think. Yeah, okay, so I'm going to come in 30 and that should give me enough space. Okay, if not, anyways, I can always go outside the edge of the border, but it'll come in 30. Okay, so what I'm going to do is I'm going to measure over my 160, which works out perfect with the set square. Okay, and I'm actually going to start and plan first. Okay, so I'll use maybe a lighter pink for the construction lines. Okay. So we know it's 90 wide. We've loads of space, but again, I want to keep it close in the hope that my end view might fit here. So I'm going to draw the center. So this will be 45 here. So I'm going to draw them down 50 millimeters. So that's going to leave 5 millimeters between both views. But again, I might have a hope of fitting it in then. So what I've done is I've come in 30, I've come down 50 from this line, I come down 100 here, and then I have my point A and I have my point C. Okay, so there's A and there's C. So I'm going to measure across 80. I want to be really technical, I could bisect that, but I'm just going to measure across 80. And I'm going to measure down 45, mark. No, 45. I'll just put a little red mark on it so it's a bit more seeable. So this is D and this is B. Now I'm just keeping that 5 mil away just in the hope that it'll fit. I'm actually even a little bit closer than 5 mil. Okay, so that's that. So what I'm going to do is, let's see, they use sort of a purple. So I'm just going to join them together. Now again, I'm going to do it solid. But what you could do is you could just do it in a medium and then come back and heavy it in with dashed lines afterwards. Okay, but just so that you can see it, and also because we don't know where our splits are going to go. Okay, so we're happy enough with that. So I have a bit of the elevation done, or the plan done, but I'm not going to draw in this. I'm not going to worry about the walkway for the minute. So what I'm going to do now is, it says draw the given plan, which I've done, and elevation of the hyperbolic paraboloid ABCD. So I suppose just for people to understand, the elevation of the hyperbolic paraboloid ABCD is basically this purple shape. Okay, so again, we know that we come up 15 here. So mark that. And again, maybe if I use just a red dot there. Okay, that looks a bit more seeable. And then it's another 64 up from that for the center point for B and D. So 15 and 64 is 79. Yeah, just double checking that. Again, no harm to have a calculator to check that. I'll just double check that when I put that there. That's, yeah, okay. I'm happy enough with that. So I'll draw this line here. Okay, so I have this line here. So what I don't have is these green lines at the minute, and we look at how to construct them. But what I may do is I may just mark out or label my points. Okay, so this is A, this is B and D, and this is C. Okay, so overall I'm happy enough with that. Now it says using the number of elements. I haven't drawn the green parts, and I think the only way to really construct them is by doing them in plan. So I'll do my division and line method again. Okay, so in this part, what you need to be careful of is the number of splits. So I initially did this question, didn't really pay too much heed, and made a mistake. What the mistake is that if you did it as you typically would, I would always split this into 5 parts. But if you carefully count it, it says 1, 2, 3, 4. And if you read the question, it says using the number of elements shown. However, unfortunately, it doesn't state the number of elements. But if you count there, you'll see there's 4 splits or 3 elements, and that's important because you'll see one of them lines up with the height of the road. So what I'm going to do first, I'm just going to draw a random line. Now last time when I drew this random line, I could have been accurate in more accurate in the last question. So usually what I do is 10 mil apart. This time I'm going to do 15 mil apart. So the bigger the gap, the more accurate you're going to be. So I have 15, 30 mil, 45 mil and 60 mil. So I'm going to join the last one. So you can see that I have 4 dots this time. And then I'm going to use my sliding set square method like I normally do. Or you could use your adjustable set square. It's hard for me to fit my adjustable set square in. And I'm going to draw these points like so. Now again, what I should have done in the last question, and I didn't do, is I should double check what would I expect to be the split. So if it was 90 divided by 5, or sorry, divided by 4, I would expect them to be about 22 mil. That looks 21, maybe a tiny bit off. 44 looks pretty good, 66, and that's the last one. So I'm pretty happy that they're fairly accurate. Again, the thickness of my purple line is making me a little bit inaccurate, but I'm just doing that check at this stage just to make sure that my accuracy is going to make the question look out. Now again, if I didn't have 100% accurate, I wouldn't worry too much, because the main thing the examiner is looking for is method rather than exact precision. Okay, so what I'm doing now is I'm just bringing these across. Hopefully we've seen there with the grey pencil. I'll mark them with the green now in 1 second. But the reason I'm bringing them across is because it's a symmetrical shape, so I can mark it without needing to do the division line on all 4 sides. Okay, so I'm now going to join this one to this one, this one to this one. That off again. Okay, so happy enough with that. Again, if I was accurate, they should all go through center points, which they have done. I'll number these, so I'll go 1 1, 2 2, 3 3, 4 4, 5 5, and 6 6. But because it's a symmetrical shape, I'm pretty much happy that 1 and 4 are going to be on top of each other. Okay, so I've marked that. That's where point 1 is. 2 and 3. So 1, 2, and 3. And then on this side, 1, 2, and 3. So what I've done there is I've drawn the hyperbolic paraboloid as asked for. I haven't extended it out to solve the plan, but I have done that. What I should notice is that if I'm accurate, this line here pretty much should be horizontal. That's the height of the road. Okay, so that's part A done. Okay, so we mark that. Now what it says is curve ABC is a parabola in elevation. I'm just going to look and see, can I solve the road? I can. Oh, I will actually have to solve it anyway. I was going to say, can I draw this line? But I need to come down 16 meters now anyway in order to start the parabola. So maybe they gave me that in such a way as to no, that's part A as well. Okay, that must just be proving a point that should be 32 in order to be accurate. Okay, so what I'm going to do is I'm going to do the parabola anyway. So I have A, B and C. So maybe if I take my yellow marker, I'll create a rectangle around it like I normally would for a parabola. Okay, so this should be very light. Okay, 64, I'm going to split it into 5. Or no, maybe I'll split it into 4, which again I wouldn't normally do, but this is 80 and this is 64. So if I split it into 4, it just makes life easy in terms of the fact that I can divide that easily. 64 divides by 4, what is it, 16? 16, 32, 48. Now again, I suppose it'd be no harm if I had done the division line method here, just to prove that I can do it. Well, I suppose I've shown it down below, so I probably wouldn't really need to. Okay, so let's just bring these into. Okay, so as not to interfere with the other bit, I'm going to do these in a light grey. I think we can see those on the visualizer. And these ones here will go from an angle. I think they're stable. Okay, I'll mark the point. Okay, so the first point and the first point cross is here, where the second line and angle line and the second upright line cross is there, and our third one, and vice versa on this side. So we'll just sketch in my parabola. Okay, so I'm just trying to see, is there a distance? Oh, wherever that comes across. I'm just trying to see how long the road goes on. I'm just trying to complete this part. Elevation, the given plan of the curved outline and projected energy. Okay, so I think I can solve this. I could be wrong. So I can see that line there goes across and that comes to meet it. I can extend this line on the walkway here, which is that line, and oh yeah, that's it. So I need to point E. So point E is 24 millimeters in from here. 24 millimeters there. Again, I'll just use maybe a red, just so that I can be seen. So I'll write point E. So that just allows me to finish this off here. I don't think I've got enough space. We have to see for the end view. Okay, I'll just bring that up. Okay, so there's my elevation done. Okay, so the difficult bit there was just figuring out, well, not difficult, but it's just something that you might spot. E is in 24. Okay, this comes across from this, and that's how far you extend it up, and then that gives you that. Now, just questionable whether I'll get the end view as a result. So the last thing, anyways, that I want to do in terms of part B is, well, I've drawn the elevation of the parabola, so that's part B done. Part C is project from the elevation the given plan of the curved outline. So what I haven't done here is, I suppose that I haven't done in the elevation is I haven't extended on 1, 2 and 3. 2 I suppose I have because it's part of the road. So I need to extend on 1 and I need to extend on 3. Okay, so I'm going to start here. So wherever 1 and 1, this line between 1 and 1 hits the road, I need to bring down that. I'll use this pink marker. And I'll extend on 1 here. And I'll just use my purple there to highlight. So that's that point. Okay, so I extended on 1 on that side. I need to do the same on this side. So bring down this point. Extend on this line 1 to hit it. There we go. Okay, I'm going to do the same with 2. Well, 2 is already being extended on by the roadway, so that's where it hits it there, and that's where it hits it there. Alright, so I'll extend on 2 here. I'm happy with that point, and I'm happy with that point. And then 3, I haven't extended on here, and I haven't brought them down here. So that's maybe where the extension hits there. So I'll extend on my generator in this view. That's that point. And that's that point. So what we'll do is we will sketch in the curve on that side. So it looks like an ellipse, but it may not be. Okay, and hopefully mine is accurate enough there. So what I'm going to do is I'm now going to do the same with, should really have these called 1 and 1 and 4 and 4 are the same. 2 and 2 and 2 and 5 are the same, and 3 and 6. So again, I'll just extend on these. That one I have, this one I haven't brought down far enough. Okay, you could also technically mirror them across, but you're going to have to draw on the generators anyway, so there's no major advantage to using that method. That's that one, and then this one here will hit here. So I seem to have them on the top, but I just didn't bring them down far enough. Okay, and then there's my point, there's my point, there's my point, there's my point, there's my point. Okay. So I now have that bit complete. So the last bit I have to do is just put in the road itself. Okay, so we can see that where it hits 1 and 4, that's the width of the road. And we know that they say to extend it on as far as here. And then they say to draw that little squiggle, which we look at now in 1 second. So I'm happy enough that that's 1. And I'm happy enough that that's 4. Okay. So this here should be a hidden detail. So obviously I could fix it up with a little bit of Tipex, but in your case you should be coming back and just making that hidden detail. I'm not going to go over that with a bit of Tipex. So this is the symbol. It's literally, it's a line that comes down, and then it's sort of like I say nearly electric voltage symbol. Okay, or power symbol. So it's sort of up. Okay, and what that means is that just continues on indefinitely. We don't know exactly where that road finishes, but it's pretty much straight both sides and continues on. So the last that we look at is, I kept it tight to see where I got the end view in. I'll just see I need a width of 95. And I'm not going to fully, it's going to go on to the drawing, but we leave it at that. We'll recover it at another stage. Okay, so that's the drawing done. Okay, or part A, B, and C of it. No, part A, B, and some of C.